Good afternoon, everyone. Welcome to Carbontech Global 2020 live webinar, which is hosted by MVideo and DT New Materials. Ladies and gentlemen, good afternoon. Welcome to Carbontech Global 2020 live webinar, which is hosted by MVideo and DT New Materials. It is very nice to see you again. We hope everything goes well with you. I'm the host, Bella.
I'm the host, Mabel. This webinar is divided into 3 sessions. Today is the second one. We will talk about the technology and the environment for processing and identification. We are likely to invite 3 speakers. Dr. Yannan Xu, the sales director at Carbon, Mr. Jörg Posch, the head of business unit Diamond, Sinova, Colin Spin, director of Lab and Research China, IGI.
Now, please allow me to introduce Dr. Yannan Xu, the sales director at Carbon. With a solid technical and commercial background, Dr. Yannan Xu has a bachelor degree, a master degree, and a doctorate. On the commercial side, he has over 20 years experience in managing sales and business development globally in technology companies of various sizes. The topic of his speech is the latest technologies for diamond processing, mechanical grading, polishing, laser, erosion, and etc. Let's welcome Dr. Yannan Xu.
Okay, hello everybody, and big thanks to DT New Materials and for them to organize such a fantastic platform for all of us to have a platform to share ideas and to get some discussions about the materials and process technologies. So today, I would like to talk about the latest technology for diamond processing and grinding and polishing. Because the latest technology, very much a lot of people talk about artificial intelligence. Yes, artificial intelligence not only can do so many things, but also can be utilized to do the diamond grinding, polishing, laser cutting, erosion. All those technologies can use artificial intelligence, this latest technology. So today I would like to focus on artificial intelligence for the diamond grinding and polishing. This is what we use this artificial intelligence on our diamond grinding and polishing machineries. So today, I would like to talk about it in general. The grinding and polishing is very much traditionally in the ancient time that people use and grinding and polish different materials. So this is the word and has been used for a long time. And so also I will touch it what artificial intelligence can do for us. And I will give you some example what we use those data recorded, analyzed, and utilized by artificial intelligence for diamond grinding and polishing. And I just also give you some idea about the Carbon's artificial intelligence used to our machineries, and we have the PG series, RG series, PL series, and FG series. And also we have grinding and polishing wheels, because as everybody knows, when you do the polishing or grinding, you need some materials to grind in the diamond. So we use grinding wheels and polishing wheels. And also show everybody my background a little bit and also my contact details. And also we have a time for question and answer. So first, I will touch it about the traditional diamond grindings and polishing. And like I mentioned, in ancient time, and people use the grinding and polishing to grinding and polishing different materials. And even now, currently, a lot of people or a lot of companies use the CNC machines to do the grinding and polishing. Those one, even though they use the CNC, I still regard them as traditional. Because that is, again, it is a machinery. So, however, the traditional polishing, grinding, and polishing, even though you use a manual or use a CNC machinery, they all heavily rely on operator's skills and experience. So if a very skilled worker and operator retired, then it's very difficult to get all those experience and skills. And but that is very important for the good quality products. So this is why for those traditional ones, doesn't matter you're manually grinding and polishing, you use a CNC machine grinding and polishing machines, they all cannot have a standard effective process to guarantee quality for your customer. And also, you have no way to manage the history and the knowledge and skills, because all of those skills and experience is recorded in individual operators' brain. Once that brain left your company, and you suffer this situation. So, and also the grinding and polishing is trial and error. And any skilled operator take years to learn those skills and experience. Through all the time, they have to do the trial and error. So that is not the way to get the guarantee control and quality. It's a very time consuming to set up each production process as well, because and maybe today you receive the order and for one customer, and then next month you receive another for different customer. So this month maybe you grinding the CVD, and the next month you may be grinding polishing PCD. So every new supplier, every new products, every new materials need new production process. And then set up a production process for different batch of products, materials, take time. So that will result no yield. And then again, difficult to control the quality. So what happened, what artificial intelligence can do for us? Like everybody know, the name called intelligence, but put the words artificial. So it is not natural human brain. It is a man-made intelligence. But the man-made intelligence nowadays, the technology is so powerful. So this is why this artificial intelligence now has been applied for many, many areas. And then we are now using artificial intelligence to the grinding and polishing for diamond. So instead of the brain and all the skills, experience recorded to individual operator's brain, we have a system. We store all those data, all those experience, all those analyses, and then store there, use artificial intelligence, that means artificial brain, to analyze it, get the best solution, best setup for production process. And then from there, we can have a standard, systematic production planning to guarantee the quality and also have a full management and control of knowledge and skill and experience. So when your operator retired and left the company, You have all those recorded there, and then the next operator can set up the machine according to previous record, previous experience. So that is very much easy to access previous histories and then previous data, previous setup for the machine. Because each machine, grinding machine, have a lot control, and the machine have to control so many parameters. So this is what, in that way, you can guarantee the quality systematically. You can reduce the waste of time to spend a lot of time trial and error. And then you also reduce the downtime, because the machine, the artificial brain will analyze when you need take action, when something need to pay attention, give you alarm to say this need urgent attention. So that give you a prediction, then you can plan your maintenance and then in advance. So that whole process will maximize your yield, increase your productivities, that means your profit. So I just give you some example and how those can increase your productivity and your profit. For example, I give you one example and say here I use 10 tools. Yeah, this operator need grinding 10 tools, say PCT tools. So after he grinding this one, all those artificial intelligence will record all of those information, like the cycle times. For each of those, it is a number 1 to 10, that's a true number. So number 1 tools, number 10 tools, and then this horizontal axis, it is a time, minutes applied. As you can see, if he or she granted these 10 tools, then it will record, and then some is 10 minutes, some is 40 minutes. So it's recorded how the setting for the 10 minutes. Certainly, that will be much efficient than the 40 minutes. If you grinding next batch, use the 10 minutes settings, that you save 4 minutes for next batch of your grinding tools process. That means 4 minutes, it is your profit. Another one, because the products like tools and so often have so many different phases to grinding. And also sometimes not only just one go, you have to maybe regrinding. So we have here record, analyze, and for example, again, this is number of regrinding. So that means you grind it once, and then you have to regrind it two times and several times. Yeah. So this is the say 0 time that starts grinding, and 2 times, 4 times, and 14 times. And also the block 1 grinding, that means that phases, and then we code it a block 1. Yeah. So these tools, say PCT tools, and have 4 phases need to be grinding. And also number of the regrinding is here. Certainly, the less regrinding times, that means you spend less time to produce the tools for your customer. The less regrinding number, that means you have more profit. So when these 10 tools, PCT tools, and you grind it, and then you choose, obviously, you choose which one is the minimum number. So these tools, for this facet, you only regrinding 2 times. Yeah, so this is very good. But this one, you regrinding only 1 times. So you just check which one is the least time, and then you get those settings for your machine. And then you apply that settings to get next batch of the tools with that settings. That means you save all the time So that is, you get the maximum, the best settings, and you get the maximum profit. That because you use least time to grinding your tools. So this is regrinding, again, less regrinding means more profit and more higher productivity for you. Okay, for example, the example 3. And also this is the, we talk about when you do the grinding, you have to make sure the compensation, because when you're grinding the PCD tools, and then that PCD tools also will wear off your grinding wheel. And then that means if say the grinding wheel and has been wear off for 1 micrometers, that means your machine measurement or the grinding wheel and push the materials, you need compensate 1 micrometers. So this is why, say we have this compensation values. Yeah. So you got this one, and then you have these 10 tools. Again, that means your next compensation. That means your wheel wear is slower. That means you no need to replace your grinding wheel so often. So those again is very important, and for those one. So you then analyze this one, and then which one, and you use a compensation value, the lowest, like this one lowest, that means the best for you. Yeah, so this is this block 2, the lowest here, and then block 4, because that different facet and need a different hardness. So often like diamond is a hardness is rely on, depends on the direction. So again, record all those data and all those settings that will help your operator, production manager to arrange the best settings for your machine. And also, for example, the training, the hard and how hard your motor to push the grinding wheel against your PCD tools. That again is important, because if you push too hard your grinding wheel against your PCD tools or other like CVD and tools, that means yes, you may be grinding quicker of the machine, and I spend the next time to grinding off these PCD tools, but again you will wear off the grinding wheel much quicker, and also you may create some and chips and some small damage to your PCD tools. So again, this need the maximum and the best settings to get the balance, and then make sure your grinding is highest speed, but guarantee is best quality, and also least wear of their grinding wheel. So all of those is depend on how hard of your grinding wheel against your PCD tool. It is depends on how high the current you give to your motor. So this is why we have this chart. Again, this vertical, each the tool number is number 1 tools, number 10 tools. Yeah, so this is 10 tools need to be grinded. And then the horizontal, that motor current. Motor current means the higher the motor current, the harder you push your grinding wheel against your tool. So again, of course, you better choose the best one, because if you got very hard, and then that means your grinding wheel wear off very quickly. So this is what, again, we can use artificial intelligence to analyze all the data. We use the 10 and tool number, but actually when you do your processing, and each day you could process so many batteries of tools. Yeah. So this and motor current. And also you can see, and tool number is here. And then we also need to get all those like the locations, the grindings, measurements, all of those one. We can get those breakdowns. And for the what is the time, and you take and break down. So the cycle, all those informations, you can record it, analyze it, and then you can get all those settings and the curve for you. Visually, you can see immediately what's going on with your production process. Again, and you when you and grinding your tools, and you will aware of your grinding wheel. It is very important, and you know how much the grinding wheel remaining. Every grinding wheel have the base and also have the surface. That surface is hard material, special materials, and to do the job. Once you wear off all those and surface hard material, grinding materials, you get into the base of the grinding wheel. Then that you cannot do anything, but actually that will damage your tools. So knowing how much the grinding wheel remaining, the thickness of the remaining of the grinding wheel, it is important, very important. So this is what, again, the machine can record it, analyze it, and then get, because that combination of the, how much you give the motor current, what is the material, how hard, because the PCD and hardness is different from the CVD or SVD and all of SAD, all of those ones, different materials will wear the grinding wheel. Some is quicker, some is slower. So again, all those information is very important to record, analyze. And again, and maybe your company have different shift, and morning shift, afternoon shift, or 8-hour shift, and so on. So every shift and the previous shift have to hand over the machine and then the product to be grinded, and then to tell the next operator what has been happening. But instead of the operator remember everything, but actually everything is recorded by the machine, analyzed by the machine. So that is a very, very important handover tools and for the operator, after operator. Another one is because this machine has its own artificial intelligence. That means it has its own brain. Yeah. So that means we can do a lot with the machine. We can manage the machine remotely through the internet, and we can know the machine. The machine can tell us through the internet or through the display unit or through your computer, through your mobile phone, to tell you what's happening. Whenever you want to know how good or what's going on with the machine, you can check it with your mobile phone through the internet. And then that means we can now offer the customer a solution. Before, every customer buy the machine, yeah, you just pay the money, and then the machine ships to you, and you install it, and then you use it. But that means you as a customer have to pay all the money in front, and then to produce profit in order to recover and your payment, that capital expenses. And but now with all those artificial intelligence, we can offer you the equipment as a service. What that means, basically, put it simple, you just get the machine from us, you just pay as you go. Yeah, you pay and say we sign the contract, and you get the machine from us free of charge, and then but you pay monthly fee to us. We manage the machine, and we make sure the machine working in the best condition. And then we get all those data for you and then set up the machine for you and everything we do. You only need use the machine to process whatever you need to process and your customer those and materials for you to process. So this, we called it equipment as a service. It is a kind of not just sell your equipment, but actually we give you the machine, you use it, and then it's like a service. You use it as you go. So normally previously, and it's called CapEx model. Now we called OpEx model, operating expenses, because you no need to pay not in front and advance and to get the machine. So that is very much change the operation of the financial arrangement for your company. Your capital, your cash can put where the most important for you to get cash flow and the cycling much quicker. That means you get more profit. Again, all of those design, it is put you in the center and we serve you as a customer. So that is just 8 example and what artificial can do and for the diamond grinding and polishing process. And maybe some customer know, and maybe some of friends and don't know. And actually, Carbon was established in 1941. We are very much focused on the diamond processing, and for diamond, and many years ago is the jewelries, and now a lot it is an industry application. More and more it is a CVD and also PCDs and extra and ultra hard materials processing. So, and also we are very much recognized and a leader in the world. And we received and top 10 precision tech solution provider for 2020, just latest award. This is a certificate we received and as a top 10 precision manufacturing tech solution provider for 2020 this year. Okay, so a moment ago we talked about very much and the idea what an artificial can do. That is very much now we put into the practice. Yeah, so for example, we have the PG series, and that PG series and can grinding many type of the materials, PCDs, CVDs, and SCDs, all of those one, and hard materials. And we can achieve below 50 nanometer radius. So that is a very, very precise, very, very accurate machine. And so this is what we can do a lot and with this machine. Another one, we have this and robot and automatic feedings and tool material and feeding the tools into the grinding areas. So this one, again, we can do very much high roughness. We can achieve 0.02 roughness. And then this is what, again, important for the PCD, CVD, and tool and manufacturer. Another one is the PL or PL series, and now CVD, and it's very popular. And now the size is getting bigger and bigger for different advanced application. And our PL series, we can kniping up to 100 millimeter CVD disc. So that is a very big size. And also, and we actually served the oil and gas industries, and 50%, more than 50%, what oil and gas drilling snags are marked by our machine. When you talk about the drill, oil and gas field, they have the drill. the drill have to equipped with a very hard materials to do the drill head. Another one is the FG and series, and then again we can do so many different type and diamond processing, and with different and axes, and we can design according to your requirement, and we can design multi-axis to help you to make the shape and for your tool processing or gem processing or jewelry processing, whichever involved diamond or hard materials. Another one, it is we talk about a moment ago. We talk about the machines. We talk about and how to say the polishing wheels, grinding wheels, and that is very much important. The grinding wheel and polishing wheel. How to make the grinding wheel, polishing wheel? What materials used for the grinding wheel and polishing wheel? All of those one also very specialized area. So we also have different 5 type of and grinding wheels and polishing wheels for you to choose according to your application. Okay, a little bit about me, and I'm the sales director and in Coben and Engineering Co Limited, and for me, and I have a bachelor degrees, master degrees, doctor degrees, and for different physics, materials, and all of those one, and more than 20 years globally, and for managing sales and business development for a lot of different products in various and companies. So that is very much and my background, technical background, but the technical sales and also technical consultation for our customers. After the auto side of work, I enjoy a lot of sports and travel globally. So that is very much and my background. And it's very nice and have the time together to share and our and technologies, latest technologies and products, and really it's good to keep in touch. So, and this is my contact details and my telephone numbers and my emails and Skype's, WeChat, and all of those ones. So this is what we can get in touch. If you got a mobile phone, you can take a photo of this one. We get in touch because diamond is so exciting sector, so much and happening nowadays that really it's good to keep in touch. So thank you very much indeed for your time and to listen my presentation. So, and I'm very happy and we have the time to have the questions so I can answer any question you have. Thank you so much.
Thank you, Dr. Shi. Here the third one. For the single crystal diamond tool grinding, does the PG4 grinding machine software provide a recommendation of orientation geometry of the SCD blank? Thank you. That's all.
Okay, so let me just go and try to, is a PG machine this machine? A moment I didn't hear clearly. Is that PG machine or RG machine we're talking about?
Wait a sec. It's wait a sec. I will repeat the question. That is for single crystal diamond tool grinding, does PG4 grinding machine software provide recommendation of orientation geometry of the SCD blank?
Yeah, and again, like this PG and series and PG4s and so on, we are working together and with our customers, and we found a single and crystal SCD and materials. Different customers require different requirement. So actually, we have our and software team actually with different customers, and we are very flexible. We can adapt our software to specifically for
specific customer requirement. So if these and customers have any specific requirement, yes, we can and adapt our software for your application. Yeah.
Thank you for sharing. We learned a lot from it. Now, let's welcome the next speaker, Mr. Jörg Posch, the head of Business Unit Diamond Sinova. He is the Master of Mechanical Design and Engineering. He ever worked as a manager and director in sales and market department for different leading assembly and robotic automation companies. Since 2011, he worked as a manager at Sinova and handling the business activities. In the natural diamond and labor-grown diamond industry. Today, the topic of his speech is the DVC system in the manufacturing process of labor-grown diamonds. Welcome, Mr. George. Welcome, Mr. Jörg Posch.
在说话了是吗？
Hello, everybody.
Hello, Mr. Hausch.
Yes. Good morning. Good afternoon, China. Good morning, the rest of the world. Hello. Sorry for the start. I'm very happy to present you the Da Vinci system in the diamond manufacturing process for lab-grown diamonds. I share my screen now. So, my name is Jörg Posch. I'm head of Business Unit Diamonds, and I'm happy to present the Da Vinci system. I have three segments. The first, some words about Sinova and the laser microjet technology. Second, then we look a bit to the CVD manufacturing process for jewelry stones in the current way. And last but not least, the main part will be the Da Vinci diamond factory. Number one, Sinova and laser microjet technology. I don't know how many people know already Sinova. Actually, it's already very well known in the diamond manufacturing for lab-grown diamonds, for natural diamonds. But here a short overview. Sinova has been founded in 1997 by our president, Dr. Bernhard Richardshagen, and is headquartered in Switzerland, in Douai. This is between Geneva and Lausanne. We are actually close to Geneva on the Lake Geneva area. We are a manufacturer of advanced laser systems using our patented water jet guided laser technology, laser microjet. This technology has plenty of advantages, mainly significant yield, improved cutting quality, as well as also enhanced capabilities for precision machining. Sinova currently has about 100 employees. We started in 2010 to enter the gem diamond cutting industry, at first in the natural industry, then later also in the lab-grown diamond industry. We do have a global presence, even we are located in Switzerland, in Europe. We have a global presence with subsidiaries in USA, India, South Korea, and Japan. In India, we do have a subsidiary with about 15 people to provide services in diamond cutting. De Beers is shareholder partner since 2015. Short introduce of our technology, who has not already heard about laser microtech technology. We are a laser cutting machine provider using a laser, a standard laser from the market, standard green laser. But in opposite to the dry laser, we focus on a special position of a nozzle with a water pump. We pressure water in a small tiny water chamber, and through a nozzle we create a water jet. The laser is constant focus on top of this nozzle, and the laser beam is guided by total reflection inside this water jet down to the cutting position. So this is actually, this water chamber is nothing else than a transformation of a V shape of a dry laser to a parallel shape in this for this cutting process, for the laser beam. We can use different nozzle sizes, 30, 40 micron, 50 micron nozzles. We have water pressure is about 350 bar. The water inject actually is only a guiding medium. It is not cutting at all. The length of this water jet is about, let's say, 1,000 times of a nozzle diameter. When we talk about using a 50 micron nozzle as a standard for diamonds, that means we have here a length of stable length of 50 millimeter. So why we are doing this, we can see here very nice comparison between a dry laser. We have here this typical V shape. This is a typical dry laser profile, IR or green laser, doesn't matter. We have here a very low, small working range with a focus point, limited working range. And when we have, when we cut thicker material, what we are usually doing by diamonds, then we have to go with the Z-axis down, and we bring the, let's say, integrate this V shape in this material. The laser microjet has this long working range. That means we have actually a cutting profile in a parallel shape. So, what can we use it? We see here very nice, and hence this pictures comparison. We do have here a V-shaped profile of a dry laser. We have a parallel profile of a Sinova laser microjet cut. The dry lasers often use then here kind of double side sawing, turning the part 180 degrees to have a double roof profile, while we have also for larger thicknesses constant the same thickness of the cut profile. So when we see here, for example, to see for the CVD, where we are now here, and we are now here in the lab one diamond market, we see here a CVD block. This is already cored, so it needs to be cut for slicing. We see here a typical profile of a slice. You go on one side with a dry laser in, you get a small roof profile. And the typical curve side is 250 micron. While when we have the laser microjet in parallel, we get many more slices out of a block with a curve of about 50 micron. We have flat 100% from the beginning, flat slices. We have automatically a higher yield in this out of this tube, and we have significant smaller curves. Mostly also post-polishing processes are required for slices cut by conventional dry laser. So actually, even not looking for this as a main part of our presentation, but as a beside message, this technology is very suitable for seed slicing. Next point, as we have heard about Sinova, laser microtech technology. Now we come to this position, CVD manufacturing for jewelry stones. So yesterday, we could see in the presentation of Tim from Element 6 and also from later on from Hildegard from iPlus, we have learned a lot about how to grow CVD diamonds, how there's a crystal single crystal diamonds, how they are growing, what you can do, and which processes have to be taken in account, and different versions are existing in the market. So now we have created our CVD diamond, single crystal diamond. We have learned also yesterday from Tim about different applications, optical transmission, thermal conductivity, stiffness, sensors, water, but I would like to focus on jewelry. So, CVD typical manufacturing flow for jewelry stones. Also, we do have here this coin. This is outside happened. This we have learned yesterday. The coin with this graphite outside. This next step would be coring. So we have also here then removed this polycrystalline part, and we have a nice core. And we have now two options. We can use it either to make seed slicing, what we have seen before, or we can also use this block direct to cut and shape a diamond. So next step in the manufacturing flow is usually you take you do the blocking or 4P, whatever. Either you take in a laser, a 4P laser to have already a rough shape, or you do this direct, as you said, you do a 8/8 blocking. This is depending on from different manufacturers how they operate. In between often is starting an HPHT enhancement process to improve the color, to improve the brilliance and so on. And then comes again the next step, the bruting. So why bruting? Bruting is for the following processes we need to have a nice part, polished part already, where I can put later on the clamp to clamp my part for the next process, auto polishing for the pavilion, or then for the next process, resetting the stone, auto polishing for the crown. And last but not least, you have the auto polishing table. So that means there are the typical manufacturing processes which are taking place to shape and polish a diamond out of this core crystal what we had originally. And at the end of the day, you have then here this finished polishing on mostly on a polishing wheel by hand. So far, it's not known that there is an automatic 100% automatic final polishing available. So this is in fact the typical manufacturing flow. So our question was from Zinova, why there are so many steps required to shape a lab-grown diamond? And now I can announce to you the CVD, the modern manufacturing flow for jewelry stones, the dream of lab-grown diamond manufacturing becomes true. From a single crystal diamond to 57 facets in one single process. This leads us to the position 3 of our presentation, Da Vinci Diamond Factory. Da Vinci Diamond Factory is our newest model, our 5-axis machine. This has been already in the 5-axis machine for coning or for blocking already distributed in the market a few times. We have machines in China. We have also machines in India, many of them. I mean, this is already existing for a while, but now we popped up this machine. We enhanced this machine for a full facetting system for lab-grown diamonds. This actually is a highly accurate CNC laser machine based on our laser microjet technology. We do have here a machine, the 5-axis machine, and we have here our utility unit where we have a laser on top, a water pump in the machine, and ultra purification unit to clarify, to bring purified water for the laser microjet technology. So what we are doing now in this new modern manufacturing flow, we have here still this growing process, what we have learned. We do have to do the coring, but afterwards we don't have any different small steps in between. We do have the shaping of out of this core of 57 facets of a round brilliant diamond. Last old process in a single setup, and this is done by Da Vinci in one machine, but is then finished by manual polishing, because this black surface we cannot avoid. This is a process which comes from laser. From the laser, this is also not final polishing. This needs to be still done by hand. How the processes are done. So that means we can go now through step by step to explain how it works. We are loading. We have also here our core, our coring core single crystal diamond, and we glue it on a dop. That's a typical dop here, and this will be loaded inside the machine by hand. Let's have a look how it looks inside. Also, we have here our crystal, and here is the planned stone inside. This looks like that. Also, here's our stone, and here is our round brilliant diamond inside. So the table is, a planned table is already on the dop. Next step, alignment process. We see here from the top this diamond, this single crystal diamond. There is already the marking. Where is the main pavilion facets? That means when we look for the marking, they would be here on top of this core. So we see it here again. Also then here, and we can even decide which facet will be the first facet we have to cut. This can be chosen by the operator. Then depending on the position in this crystal to get the highest yield out of this crystal. So this is in fact to have a perfect match between the machine and the cost of this, the position of this stone. So next step is import of stone data. We do have a couple of options, few options to load the stone data inside. What you can do, number one, would be we load data from a scanning machine. There is it gives this CSV files out of these scanners. There are different scanners already in the market. Sinova does not produce scanners. So we can use these CSV files where a lot of data is already in a that rows, the girdle diameters, table size in percentage, the cone height, and so on. We can also load these data direct in the machine. This would be one option. The next option is, for example, using open format files direct. If we have them, that means we can use STL files, the 3D files, or typical X files called X files. They are the files for the parameters of this stone. Of all positions of each corner of each facet. This would be a second option. Yeah, and last but not least, the third option would be to use a dedicated wizard, but is available on the machine to simply put data by hand. We see here again girdle diameter, table diameter. So that means this is data maybe you to take out of the leaflet of the stone. If there is no other way option there, then you can take this as a third way to load these data. So next step is creating polystone shape. So now we have loaded the data, we have this crystal inside, and then will be the diamond calculated based on the imported stone data in this crystal. We have also here this typical mathematical diamond model. And then we create this stone inside a crystal, and this mathematical model creates the NC program to facet to provide the facet cutting process. We can also turn it here in different options to see it. And next help for the operator is even to have a simulation program. So that means you can even run a simulation before you start the shaping process, that you can see each facet, how it will be shaped. And we, let's say, can even say, okay, show me the finished stone. This would be the stone after the process. You could even see, in case you would load data which are not matching with the crystal. You would even see that there is something out of reach inside the stone. That means in this case you would it's a kind of, let's say, anti-collision test simulation. So when we have done all this, we do this facet cutting. We can start actually facet cutting. We see here very, very nice live pictures, very nice taken by a photograph. So we have here our stone, here is a dot. Usually the stone, all the facets are cut in a horizontal position. That means you go with a laser direct here on this stone stepwise from facet to facet. We see here as a beside message, very nice, is a water jet with a laser beam inside. That means this process is only possible because of the laser microjet technology. When you do this with a dry laser, this is peak, this is V-shape, you will not be able to have a perfection in the cutting process. So this is here, actually all the facets are done in a horizontal way. One process, this is voting. The cut is done in a vertical way. Yeah, also very nice here. And again, there is no stone resetting required from pavilion to pruning to crown. All is in one relation to each other, accuracy relation. This facet cutting requires a process that is called breakthrough sensor. We have, of course, to know when each facet has been cut. The facets have, depending on the stone shape, often different times to be cut. So that means we need a dedicated automatic sensor what is detecting the end of the facet cut, that we switch automatically to the next one. The operator is more or less doing nothing. That means this process he can do in the meantime while the stone will be shaped. So he can do different other operate. You can already do a new stone, or you can operate already a second machine. So also this breakthrough sensor takes care that after each facet cut, the signal comes to the machine, and the next step come back to these pictures, and this revolver, this rotary axis turns the stone to the next facet. So, and you can easily even also visualize this on a screen to operate, to see from outside on which position we are just in the cutting process. So here are some typical pictures from the main pavilion facets or have been already cut. We have stopped here this process only to take these pictures. Once again, all is done in one setting. There is not one resetting of the stone required, but is automatically leads to inaccuracies in the cutting process. So, also after all these processes, 57 facets have been cut. This is also a true stone. I have even here with me. This is a 3.2 carat stone out of a CVD block. But we cut it, what we shaped ourselves here. This is in fact the result. We have, of course, here a black surface, a black skin. This needs to be done outside the Da Vinci machine. This is not part anymore of the Da Vinci. To follow all the facets, to polish, to create, to remove this black skin in a smoothing process. This is in fact not a typical polishing process where the operator, the polisher, then repairs the stone or needs to create his own version to shape it, to shape the stone. Actually, he has only to follow each facet on the polishing wheel and bring the shine in the diamond. The skin is typically 25 micron around. That means you can, this is actually a final smoothing process, not really a grinding, polishing process. So, and your stone more or less is finished. Some specification data. We give what we have learned. We have an input, we have a lab-grown diamond with a flat table. The cutting time, and this is surely for you the most interesting part. We shape 1 carat out of a, let's say, 4 carat rough CVT crystals in about 1.5 hours. This you will not reach in any other operation. Accuracy is about less than 5 micron. Typical stone sizes for the system is 50 pointers up to 4 carats polished size. That means you can say maybe 1 carat up rough to 15 carat rough if required. The cut grade, we have reached already out triple X results. This has been verified by IIDGR, as a former IIDGR, nowadays the various industry services certificates, and below, some of them were also very good range. From the shapes, we are currently having in the machine around brilliant shapes. The fancies are in development in a very short time, that we will be able to integrate all the different fancy shapes. I will come in the next slide about. The surface finish is also very smooth. Actually, the surface quality is about 250-300 nanometer for this black surface, but needs them to be smoothed by post-smoothing process to finish. So what is our next upcoming projects? I told about the integration of fancy shapes. There are a lot of shapes already in the internet. You can find a lot of them, marquise shapes, usher shapes, Pier Trillion, which are already in STL format files there. So that means what we have in mind is to take these files and integrate them in, for example, a typical CVD block, and start cutting of this out of these CVD blocks according alignment to these STL files. So the benefits. So what we do have is in the lab-grown diamond, we have our reactors that we have seen yesterday. We have a fully automatic process for the reactors and for this growing process. So why not combine it with a fully automated rough to polished production process? That means actually this machine is a logical automated following process from these reactors direct to the machine. We saw that on the beginning there is an operator puts this stop with the glued stone in the machine. I can tell you that we already tested to bring a robot, come with a robot size in the machine to load and unload this part with a 6-axis industrial robot. Increased manufacturing flexibility in terms of location and demand. So it means, what is the current status when we come to the current way of manufacturing? There is maybe the growing process in one country and the manufacturing process is in the other countries, maybe in these traditional cutting centers, wherever it is. So that means we are shipping now the parts back and forth. Everyone is charging the other depending on different weights. So here we could install a machine either close to a producer. That means the grower of this product can also then manufacture polished diamonds, or we can put it to a retailer shop. A retailer shop could maybe have, let's say, 5 different or 10 different crystals there. In the morning, a customer is coming and say, I would like a heart-shaped diamond, and instead of having different sizes of heart-shaped diamond and then different sizes of round brilliant diamonds and marquise and maybe just this pearl shape, but the customer would like is not available, so that means you have to wait. No, you can take one of your crystals and you can match it with one of these softwares, and you can produce it in one day from the morning till the afternoon having a polished diamond. We can also say grown in location X and manufactured in location X. For example, when I see the country China, the country China has now mining process for natural diamonds, so that means you have to buy the stones from outside. But you have a huge strength in growing of diamonds. So that means in this case you can say instead of shipping them to other locations, grown in China and manufactured in China. With this machine you will be able to manufacture your diamonds close to the producer. We do have a higher and more predictable polish yield due to a constant high manufacturing accuracy. To why it comes, as we don't have to reset a stone, means we don't bring each time a new inaccuracy in the process. All is this pavilion, it is then the girdle, if it is the crown and the table are aligned to each other in the accuracy. So that means this gives this predictable polish yield from plan to polish is over the entire production much more constant than to compare to a normal manufacturing process in a conventional way. We have additional increased stone yield to reusable chips. We don't polish anything away besides this 25 micron skin at the end. We can take all what we shape, these parts falling from the crystal can be reused and can be used in industrial application. No need to throw them away. You can even, when these stones, when these chips are still large enough, you could even take a smaller stone out of it. And environment advantages. Lab-grown diamond industry is more or less very well known for ecological applications. So that means here we have a strongly reduced ecological footprint. We have virtually one diamond machine in manufacturing in one system. Last but not least, coming back to these shipments, we are just currently holding this webinar because of the pandemic. We cannot travel. There is no shipment back and forth between the countries. So that means, I think, coming back to this point, there is, let's say, a no-brainer to say, I need this machine close to my producer to avoid to ship permanent my parts back and forth half of around the world to create a lab-grown diamond. Yeah, here I'm already on the end. Da Vinci Diamond Factory, a fully automated faceting system for lab-grown diamond. I can only recommend this to anybody. Here are my contact data, including the WeChat. I'm looking already forward hearing from you. You can take it direct from the screen. And that's it. I'm here already on the end of my presentation.
Thanks for sharing, Mr. Yokpausch. That was a wonderful speech. So now, yeah, we will also collect 3 questions from the Q&A part. So let me check. Okay, Dr. Pausch, Mr. Pausch, I'm sorry. Here the question 1. What is diamond breakage ratio in Da Vinci laser? Thank you. I'm sorry, Mr. Pausch. I'm afraid I didn't open the microphone. Yeah.
Hey, hello. Hello. You hear me? Hello.
Yes, yes, yes.
Ah, okay, yeah. Yeah, so actually we are providing already this technology to our to the natural lab-grown diamond industry for normal cutting processes. And we recognize that the diamond breakage rate is significantly lower than any other dry laser, because in fact our water jet to where the laser beam is guided is cooling this diamond. That means actually the entire process is on a much cooler cutting process than with any dry laser, whereas a heat impact actually leads to damages. Also our damages rate is not zero. It is not a gluing machine. It is still a cutting machine, but the damages are significantly lower.
Yes, thank you for answer. So here the second question is, what is the lifetime and the replacement cost of the nozzle? Thank you.
Very good question. Already some experienced people in the team. Actually, for the nozzle, actually we estimate a lifetime about 2-3 weeks. We are using for this shaping process diamond nozzles which have a higher stability and higher lifetime than the usual sapphire nozzles, but we provide for regular cutting operations.
Thanks for your answer, Mr. Pausch. Here is the third one. Does this machine works for CVD diamonds only, not HPHT diamonds? Thank you.
Yeah, I was expecting this question. I must say, first of all, we tested this system with natural diamonds. So that means here is the unique shape of a natural diamond works, of course, well. In this case, it works, of course, also for HPHT diamond. Also for the machine, for the laser process, it doesn't matter if it is a natural stone, HPHT or CVD. Let's say the CVD block has, of course, small advantages as they are always in a similar regular shape. Also when I have my CVD reactor and I produce 4 carburetors, so that means they are all looking rather similar. Where you have a HPHT process, the shape might be varying, but it doesn't matter because we are used this already for natural stones with any unique shape.
Okay, thank you a lot. Thank you, Mr. Pausch. For the rest of questions, we will save it to the next part, the round table discussion. So anybody, if you have any questions, please raise your hands. Click the raise your hands button that you can speak with the speakers. Okay, all right. So let me introduce our last speaker. That is Mr. Colin Spear. He's the Director of the Laboratory and Research China at IGI. He is the manager of IGI China Education and Marketing Department, experienced gemology instructor whose career began as a grader on diamonds in IGI laboratory. During his stay overseas,